Efficient warehouse management is not an easy endeavor. Moving goods from one location to another is a repetitive, time and effort-consuming task. Using a robot fleet to perform these tasks improves the efficiency of warehouse operations. The robots relieve the operators to do a great amount of heavy work. However, internal robotic tasks, such as locating, or navigating in a safe way, requires a great amount of the computational resources. This constraint doesn't allow us to use more advanced technologies inside the robots. Decenter empowers the robot fleet with advanced technologies that could not be applied before in this use case. This demonstration will show the capabilities of Decenter applied to robotic logistics in warehouse environments, integrating artificial intelligence, and showing the power of containerization applied to a robot fleet. Traditionally, the robots run its software directly over the operating system, that is called bare metal. That brings some problems. Each robot is factory set up with a specific set of software versions. With time, an update will be needed. If an update introduces a bug in the system, there is no easy way to roll back to the previous state due to dependency problems. Decenter brought the cloud-native technology of containerization to the robot and edge devices. Now we can have each software part in a separate microservice with all requirements encapsulated. That allows us to switch versions forward and backward without the dependencies problem. The robotics logistics need a software placed on the edge that coordinates and optimizes the robot's routes. In our case, it is the fleet management system. It receives the order from the operator or automated devices and generates the optimal mission to move goods from one place to another. Before, the robots acted as individuals, only communicating in a centralized way with the fleet management system. They can only use its own hardware to run all the robotic software, even if they are overloaded. With Decenter, the robots and the edge devices behave like a swarm. Now the robots can share computational loads among idle or charging robots and edge devices. Due to the battery-powered nature of the robots, lower load means longer working periods and lower downtime. In the traditional way, the robot path planning is done without considering any dynamic changes of the environment. Any detection of a path-blocking obstacle will be assumed as the worst-case scenario. A human. And for safety reasons the robot will stop. Frequently in real warehouses, goods are outside their assigned place, obstructing the vehicle's path. In this case, the robot will wait until the object is manually removed or the mission fails due to timeout. The fleet management system is unaware of the nature of the failure. It gets worse if a second robot is commanded to use the same path after the first. The first arriving unit will be double blocked by the second robot and the obstacle, leaving both missions unaccomplished. Decenter brings the system the ability to identify obstacles using AI. With this information, the fleet management system can make a smart decision. If another robot is detected, a temporary reroute will be performed to complete the mission. If there is a human, the robot will send a visual and acoustic signal so the worker is aware that he needs to clear the path. And finally, when there is an unknown obstacle, the route will be blocked for all robots and the alternative path will be used. Using this data, the fleet management system can ask a worker to manually remove it. Thanks for watching. For more information, visit the Decenter project website: www.decenter-project.eu.